Hi, Toyota Denso. I know that you dislike it, at least a lot of you. And I think that it is the moment that we can just show that the Toyota Denso 2026, this example, so the newest one, 2.8 turbo diesel, it is not so complicated. First, let's start from the typical common problem, how to add two-dimensional maps. There are various versions of the structures. They are the structures, of course, single point, that, like in a Bosch or Siemens. There are the structures which are two-dimensional, and finally three-dimensional maps where the axes are before. First, let's see the two-dimensional map. In most cases, WinOLS will show you maps, so it is easier. But for two-dimensional maps, this may work, but for one-dimensional, not always. Let's look for one-dimensional map, so single axis and then the map. Okay, I just look for limits. Still not here. Okay, here we have some limits. So if I do not have any detection, in that case we have a detection as a Denso. So WinOLS will help. If there is no detection, you should just go to the beginning and just find one difference. Because in Bosch, after the length, it is just already properly set if you just use the function to make a columns. But here not, because there is a one difference. For Denso, it is still two-dimensional map, but the second dimension is 0. So this won't work, but WinOLS won't help you if you just select this two. So if there is no detection, please use following thing. Find the length, make it 28 columns in that case, then just move the real beginning of the map, which is not here, but here. This is the axis, of course. So below there is a data. And now if you add this, this will work. So we have the one-dimensional map ready. What about two-dimensional maps? Maybe first sequence maps, so three-dimensional maps. If you just find a sequence of many maps, give me a chance. For example, here, yeah, they are touching each other. So at the beginning of this, you will have always three axes. First, second, third. Third is a selector. So, for example, the first big map will be for value 100, whatever is this. And the last will be for value 2000. So this is still acceptable. It is not a big thing. We understand that we have dimensions here, so we can just arrange it even it is not detected by WinOLS, especially if you are using the older WinOLS. All right, and now two-dimensional maps. Two-dimensional maps have spikes in a code. Probably you. Okay, so here is the map. I will just remove it from here. All right, how to add this map? The map has only one axis because the second axis is inside. So this causes these spikes or spikes up, spikes down to exist. How to solve? See, just add a map with the dimensions you see. Of course, if I just go to the beginning of this map and check dimensions, it is 15 by 15. But using this won't help because, in the matter of fact, this map has 15 lines, but it has 15 rows, but it has 16 columns because the first one here, maybe I will change the selection mode. So first axis is here, is inside the map. Okay, I will just add this as it is. So this looks like that. Here is the axis and this is the map. We cannot add the x-axis because it is length of 15 and here we have 16 columns here. Let's try to solve the axis first. I will just go and take the start address of that axis. So start address of that axis, it is just here as it is inside the map now. So I copy the address, I go inside the map. I just add this address to the information about the location of the map. Okay, but the proper value is every 16 values. So there are one value of the map of the axis, then 15 values of the map. So this is not a true axis. This is just the information taken from here, as you see. It is 683, 683, 790, 790. So then we should just use skip bytes. See, they are bytes. And every data, it is a 16-bit word. So in that case, we should just skip 15 16-bit words, which means multiply by 2. So this is just the 30 bytes. So I add skip 30. And now, of course, this axis is not pretty, but now you see we have a proper axis. So nice. If we just go here to hexdump, we will see that the axis is added. But the map still has the axis inside. If I just go to 3-dimensional view, this will look like this. The axis is here. Let's remove the axis. So if we remove this axis and have a really 15 by 15 here, we can add the top axis. I go inside here, and here we will just use not the skip bytes, but the skip bytes. Skip bytes per line. So we should just skip every 16 byte. So go to every 16 bytes. So I will just skip here 2. So I skip the axis. When I skip the axis, then the dimensions of the map are 15 by 15. So I can just go like this. But as you see, this axis still exists here because the proper start of the map is here, not here. So in that case, I move 2 bytes left. As you see, now the map is properly set. I add the top axis then. But top axis does not start here. It starts here because it's only 15 of the length and we have the 16 columns. So I just select the proper start address and I tell this is the x-axis. And now, as you see, our map has a proper axis and we can just use it and utilize it exactly like in Bosch. Notice that the same situation happens if you just think about 32-bit float axis. When we just go to the area of the float maps, which are slightly later in a file, okay, I make it narrower, and we zoom it, we will see it is possible that we will have 2 axes at the beginning without axis inside. So then it is easy. We remember the rule about the information here at the beginning. It is possible we will have the float maps with the axis inside. For example, I think here. So we see this is the axis inside. So this causes a bit of trouble. It is a sequential 3-dimensional map. So we will have 2 axes at the beginning and the, for example, third value inside. And it is possible that the structure will be like in Bosch. So you must be flexible. You must be flexible with that. And then we can just go further and start to think about first we will talk about the tuning of the Denso, how to do it properly. And later, maybe something more complicated in Ghidra, we will just start doing some magic. You are welcome. Okay, bye.